the respective coordinate point. Now, what we will do first, but our main task is we have to put unit force. Put unit force at coordinate 1. Put unit force at coordinate 1. That means we will put moment at A equals to 1. Okay. So if you draw the diagram, then you will understand structure into, we will convert the structure into our statically determinate structure and BC. What we will do, we will put unit force at 1. We will put unit force at coordinate 1. That means at 1, I will find out elements delta 1 1 and delta 2, because this is coordinate 2 and coordinate 1. So due to A, which is the coordinate 1, okay? Okay, so we will just put each moment at this end, and all the remaining beams will be just as it is. So now I will draw the bending moment diagram. So we draw the N by E diagram. We all know. So let us take it as it is. So M by EI diagram will, okay. The and this today there is some problem in the net, okay. I will rather tell you that to join in the Google Meet, because there is some problem in the net, okay. It is very difficult. Okay, just as it is there, just take it, okay. There is a net problem I am seeing. So what I am doing, please understand this thing, because you have notes in your copy. Force equals to 1, that is n equals to 1. How? Okay, I told you last day only. I have told you last day that force meaning in matrix method, this force. In matrix method, the force meaning, we can put force as 1 or moment as 1, because this is a generalized force. Please remember, in matrix method, force can represent both things. Either vertical force, it can be point load, UDL, whatever, or bending moment. I told you from the very first day that in matrix method, force, that means a general term force. The force is used as a general term to represent either vertical force or bending moment. And displacement is a general term for either vertical deflection or slope. Okay. So force can be vertical force or bending moment. And here I have taken the redundancy. I told you we had taken the unknown MA equals to unknown, MA unknown and MAB unknown. So what I did, I put the bending moment 1 kilonewton meter at this point. 1 kilonewton meter at this point A. Okay. So at point A, So if I just put 1 kN bending moment, then the bending moment M, then M by M will be like this. With respect to this, diagram, why it is triangular like this? Because M is 1, so 1 by EI, and here no bending moment here, no bending moment, no bending moment. Okay, that B dash. So this is if I take this conjugate beam, again we will apply conjugate beam method, something like this. If you take conjugate beam, this is B dash and this A dash. Okay. So with respect to this case where I am putting unit force at this point 1, then my elements will be first is delta 11. Delta 11 will be the force at point 1 due to, sorry, the displacement at point 1 due to unit force at point 1. That means the force at point 1, that is force, first position is the after effect. That means displacement at point 1 due to unit force at point 1. So this will be what will be with respect to this text. So we will take this distance, that is two-third into the length into area of the triangle. Two-third into length into the area of the triangle. So half, so two-third of the area of the triangle. Two-third of the area of the triangle. This is the area of the triangle and two-third. So two-third of the area of the triangle. This we are getting A dash. That means what we are doing for this left end, that is A dash, we are taking this distance. For this left end, we are taking the right side distance. I've shown you the CG. So for the left side, we have taken the right side distance, and for right side, we will take the left side distance. So two-third into area of the triangle. Two-third into the area of the triangle. So the delta 11, the element is coming 4 by 3 EI. Delta 11 is coming two-third into this length into the area of the triangle. Okay. And delta, what will be delta 21? Delta 21 will be at this effect. Delta 21 will be the displacement at 2 due to unit load at 1. Displacement at 2 due to unit load at 1. So this will be the left side distance. One-third into the area of the triangle. So 2 by 3 EI. 2 by 3 EI. So this is nothing but this is always the area of the triangle. Area of the. So this is the case 1. So case wise, so at individual cases, we will put first unit force, that is unit bending moment at A as 1, and the second case we will unit bending moment, that is bending moment 1 at point B. Because I have taken two coordinates, point 1, point A is coordinate 1 and point B is coordinate 2. So this is case 1. I have put the unit force meaning moment. So with respect to this, what is the outer effect? What is the flexibility? The elements, okay. In flexibility matrix, we have to put the values of the elements. So row wise, sorry, column wise, see, column wise we have got this, we have got this. case 2. Then we will go for case 2. So please remember, whenever we find out the elements of matrix, whether the elements, whether the matrix is a flexibility matrix or stiffness matrix, we will calculate case wise. Case 1, for example, if we have n coordinates, then the cases will be n number of cases. More the number of coordinates, more will be the cases. Okay, so case wise, at respective case, we will put the unit force. So please take this down. If you have taken down, you can write in the chat box. That's done. Then I can go to case. So please, very important thing, how we are finding out a dash delta 1 is the left side. So at this left side, we are getting 2/3. We will take this portion. Okay, we will take this portion delta 1 and this is delta 2. Delta 1 and delta 2. This portion you have to slightly remember that which distance you will take, how much you will take. Just so it is better you draw the CG diagram. So from the CG to this distance for a right angle triangle, this distance is 2/3 L and then this portion is 1/3 L. So can I go to case 2? Those who were in between of this video, there were net issues. So now it is coming clear. You can do this. I had sent all the notes. This class is for your understanding part. Okay, how to formulate or how to develop the matrix. Okay. Now can I go to case 2? Just take this down. If you have taken down, then I can go to case. Just take down slowly. So now I am going to case 2. I hope everyone have taken down this portion. Everyone have copied successfully. If you okay. Next we are going to case 2. I hope everyone have taken down. Any problem? You can write in the chat box. I have got reply from only one student. That is why I am asking. 2 to 3 students, if you write in the chat box, that's done, then I can proceed. Okay, thank you. Now coming to case. See, very interesting. So in the case 2, you will see what we are doing. Case 2. You will write in the exam copy also, you will write in this fashion, proper. So put in case 2, we are putting unit force at coordinate 2. Put unit force at coordinate 2. That means what? we are putting moment at B equals to 1 kilonewton. We are putting the moment at B equals to 1 kilonewton meter. So in the case 1, I put MA equals to 1 kilonewton meter, and this case I am putting MB equals to 1 kilonewton meter. So I will draw the diagram again. AB. Then I will draw the diagram for BC. So this is coordinate 1 and this is both are okay. Now coordinate 2, mind it, coordinate 2 is for B, that is sharing both the beams. So I put here 1 kilonewton meter or moment MB equals to 1 kilonewton meter, because I have to put unit force here. So I'm putting, so instead of here, in first case I have put here, and in case 2 I have put the bending moment. Okay. So draw the bending moment diagram. So I will draw the N by I diagram like this. Okay. So here it will be 1 by EI. The maximum magnitude will be 1 by EI. So we will draw the 1 by EI diagram like this. Okay. Very nice. So next I have to show the CG distance. So I am putting the bending moment at B at 1. I'm putting bending moment 1 at B, and I'm getting these two triangles. Why two triangles like this? Because point B is sharing on both the beams. Point B is sharing both the beams AB and BC. Okay. Point B is sharing both the beams. B is on both the beams AB and BC. So if I put here 1 kilonewton meter, so my bending moment will be like this, 1 by EI. Again for BC, it will be like triangle like this. So for this case, I have to find out what it will be. My elements will be delta 1, 2 and delta 2. Delta 1, 2 and delta 2. So delta 2, 2. So this is the diagram. So delta 1, 2 will be the displacement at 1. Please listen. The displacement at 1 due to 2, and delta 2, 2 will be displacement at 2 due to 2. The first is delta 2, 2. That means at delta 2, 2, that means what is the displacement at coordinate 2 due to unit. So I am putting unit force at 2 coordinates. See, I am putting the unit force or unit bending moment at coordinate 2. So I am getting delta 2. So for delta 2, 2, it is lying on two beams. So I will take the effect of both the beams. The first is for beam AB. Then for BC, 2/3 of area of the triangle. So for this case, for portion AB, it will be like this, and for BC, it will be like this. See, I've shown the diagram. I've shown you the distances also. So total it is coming, delta 2 is coming 7, and delta 2 1, but delta 1 2. Delta 1 2 will be 1/3 into area of the triangle. So 2/3 of here. Okay. In this case, I've got again the elements column wise in this fashion. Just wait a minute, let me take your attendance. So check this out. So delta 1, delta 2 2, and delta 1. Please quickly write this down. This one. So if you have understood case 1, you can easily understood case 2. Delta 2 2 and delta C. For delta 2 2 at this end, so B is the right side, so left side is 2/3. So 2/3 of the area of triangle plus B side is left side, so right side. I will take the distance of the right side. This portion is for this diagram, and this portion is for this diagram. Copy this down, then I will go for the next step. So in the case 1, we have got delta 1 1 and delta 2 1. That is the elements of the first column. Check, you can see we have in the case 1, we have calculated delta 1 1 and delta 2 1, elements of column 1. Second, in the second case, we have got delta 2 2 and delta 1 elements